Solana clearly has something with like the on-chain club and all of this stuff and the ability to have like efficient price discovery. You have a world to make Solana effectively the like global routing hub where everything like routes and you do execution there, right?
Yeah.
And so like,
I think that's the end state.
OFT works differently in that we don't touch the token stack. So this could be any token. This could be token 2022, or it could be SPL, right?
Yeah, exactly.
It has the mint and burn authority, and this part is owned by the app.
Hey everybody, welcome to the Endpoint. I'm Bryan Pellegrino with Ryan Zarick. Today we have Matt Sorg, VP of Tech at Solana Foundation.
Great to be here. I'm excited.
Yeah, so we're going to be diving through technical side from both Solana and LayerZero. I think the goal in general is just kind of go deeper than most people do. So I think we're going to start from the Solana side, specifically talking through Solana architecture, some of the biggest architecture changes you guys made, both early on and now how that's developed. What those trade-offs have been, your guys' stance and reasoning. We'll do the same on the LayerZero side, and then I think we can get into some of the more interesting stuff.
The real impetus of all this is just, if you don't want to have a market be made in one single location, you want to have it globally and synced as fast as the speed of light will allow. How do you do that? You probably can't have one individual server because then everything will just consolidate around that. So you need some way of distributing it. And it needs to be performant to be able to handle like that global scale. If you're doing like one transaction per hour, then it's probably not that interesting. So I think the first thing that was kind of like the 2 cups of coffee and a beer kind of, that is like a old wives' tale about Tolly's initial inspiration, was basically how do you keep a leisure schedule that is distributed with an arbitrary number of nodes where people can't skip the line. So like there comes an issue with creating consensus around the world or against multiple parties. Like you could just preform a block and just insert it and be like, I went before you, you were tardy, or whatever. So how do you determine as a network when there is no atomic clock that is just some universal thing? How do you tell in like block time, blockchain communicable time, how the next validator is running and if the order is preserved? Because if you can solve that problem, then you can have a well-formed leader schedule and everybody knows who to communicate with at any given time, and it's provable. And so that's where proof of history came from. It's at its core, it's just a verifiable delay function, but it allows the entire network to know who should be going at that time, what happens if they don't go. So there are skips in blockchains all the time for whatever reason. So that was like the first thing that was solved with proof of history. I think the thing that probably people don't know is that in order to actually execute the entire stack in a really, really performant way, basically the entirety of what you consider a blockchain was rewritten. It's the ingress layer to the way that the blocks are packed, to the actual execution layers in parallel, to even the distribution of the blocks out to the network are done basically in a streaming fashion, which is so they're not quite blocks in the way that other blockchains build blocks and then produce a bundle. They're more streamed and then checkpointed, and that makes the checkpoint is essentially a block. So there's a lot of design decisions in there, obviously, but every decision is kind of made incrementally towards performance and satisfying that original idea of syncing the world state as fast as the speed of light will allow.
So Ryan, you were the biggest proof of history fanboy that I knew when you read the paper. I think you were a total maxi. I think when you, in early implementation anyways, I think there was some delta between the way the paper was written and the way the implementation, do you remember any of this? Do you want to talk through it at all?
Yeah, so from our early days of working on Solana, it seemed that some of the paper had gaps. I can't recall exactly what it was, but you guys didn't
absolutely no surprise.
Yeah, you didn't quite implement exactly what you were going for. In that, I believe one of the things I really loved was you could tag any transaction. You could basically, if you had seen something get submitted, you could attach yours to that to make sure that yours came after that. And so that preserved order versus allowing them to reorder, because they couldn't put your transaction ahead of one you've already seen if you knew that hash. And I believe you guys didn't implement that, which I thought that was one of the cool censorship resistant ways, or allowing it could prevent, I guess, a miner from having fun with how the order is if you want a transaction to happen in a certain order.
Well, the order is preserved now by every shred that goes out has a tick, proof of history tick, and the next one is based on that previous one. You can't generate out of order because you need to have.
But within what has been submitted. So once someone has completed a block, so whoever's making the block, anything they have, they can order it however they want, essentially.
Sure, but only sequentially based on the shred output. So like the minute a proof of history tick, which is one shred, we call them shreds. So that's like the streaming process. There's some amount of compute, then you produce one shred. There's a proof of history tick of that shred. So, but the next proof of history tick is made off of the previous information. So that within each of those shreds, you can the leader reorders as they can just like any they're responsible for ordering the transactions within that. The thing that can't happen is a shred gets produced out of the network and then they inject some transaction into a previously shredded out propagated shred.
When someone is creating a block and they're the leader, whatever block that they produce, that is final, is what you're saying, right?
They cannot recreate and put some reduce some block. Well, you could, but it'd be a forking event of that. Like you just keep up some live forks and then whichever ones are voted on, and it gets really technical, potentially even outside my depth. But a single leader actually has a really hard time doing that if they are producing, because you have to have, in order to get sufficient votes, you have to have the same hashes.
But I believe the paper had talked about how I could essentially tag a transaction that gets put in. Like I saw a transaction that hasn't been mined yet, or hasn't been put into a block yet, or finalized in a shred, right? And I could say, I know that ID. I'm going to tag mine I want mine to follow that. So you know what happens in time.
Oh, interesting.
But I think that's one part you guys just did. I don't think you needed to, but it was a cool feature to prevent the concept of like that being censored out because mine now is dependent on that one, and then that it would make it so that mine would have to come after that one succeeded.
Interesting. Well, you can do within a singular transaction that you send. You can have that can be atomic with a bunch of instructions to them. Subsequent transactions, though, that's interesting. Yeah, I'd have to look at that. So frankly, I guess maybe there's a macro point here. One, Solana engineering as a culture, or whatever you want to call it, as an ecosystem, very practical. So things have all over the place departed from the exact spec that was described in the white paper. And that's kind of on purpose. Like in practice, when you are actually, having thousands of operators of a network and, slightly different whatever standards and geolocalities, like there's a lot of nuance to something running in practice that just iterating on that and what you see in ingress patterns and the way different RPCs even submit transactions to which shed of the network, all that stuff has like some pretty big ramifications. So you have to react to that and how you actually architect the thing. So that one is just completely known. There's actually this joke. There was recently some Waterloo or some university was doing this like white paper reading list, and somebody asked if we would like to submit anything, and we're like, we're good. don't read ours. So just like look at the code. Like the code is the implementation, and then we have a SIMD process, which is kind of like the IP process that describes the next specs that would be consensus breaking after them. Other than that, the white paper doesn't necessarily viewed as canonical. It is a historical piece, just like the 2 cups and a beer are at this point. Yeah,
for sure. I remember early on though, when he read it was the first time. He didn't get really excited about many technical ideas, and the first time post proof of history, he was pretty excited about it, which was really cool. It was a cool paper. LayerZero aside, the way we've always thought about it internally is effectively if the internet was pre-internet, you have bunch of distributed execution environments, you have Stanford, you have DARPA, whatever, you have this miserable problem of I want to run this data in some program, I have to fly there, right? Invent the internet stack, you have distributed execution environments now that can talk to each other. And a packet is basically compute, you generate some array of bytes, you move the bytes and you ingest them, you do something. So you compute on both sides with an array of bytes in the middle. LayerZero at its core, the way that we think about it is arbitrary contract invocation with a bytes array. We built it with the intention of having multiple varied distributed execution environments, which is all a blockchain is, be able to talk to each other and send effectively this packet. So the goal was, one, have that be as lightweight as humanly possible. Some of the early, there was IBC, a couple other like messaging standards at the time, but they had massive headers. There was like a lot of overhead in doing this. It was like fine in Tendermint, but like miserable for the EVM, just like completely impractical from a cost perspective. So one was like really this small, low-level packet that allows you to kind of have this communication without any extra set of enforcements. If you're going to do something in a smart contract, you should be able to do it across LayerZero. And then the other thing that we cared very deeply about, which I think we'll get into later on today as a touching point, is early on we thought from a very EVM mindset. So like immutable, permissionless, censorship resistant were like the three things that we talked about. So immutable was obviously the ability to not modify any of the smart contracts. We thought if you have a developer building on top of you, so at the time you're looking at the Aaves, the Uniswaps of the world. So what's it going to take for these groups to like build something with $30 billion on top of this tech stack? Obviously, they shouldn't need to trust that we're not going to go in and be able to modify the underlying code and like rug them, right? Like they're not going to hand over the security properties of that. So we thought we have to give pure immutability to the endpoint side. Obviously, there's a lot of trade-offs in that. The way we handled it is that there's a append-only library of validation libraries. So anytime there's new techniques for validation, anything that you want to add, we can add it, but it's opt-in, and we can't remove any of the existing, and we can't change any of the existing. So anybody can opt into any new features, but if you're on a library that's been in production for 2.5 years now, done like $60 billion of value transfer, like has never been hacked. If we publish something new, like you might want to wait a year and see before you migrate like a massive amount over, right? So that's how we dealt with kind of progressive features within the system as well. And then the censorship resistant permissionlessness. Permissionlessness, which is obviously anyone participate, but censorship resistant, we thought it was very important to make it so that, one, if we are bad guys, the labs is malicious. 2, the office blows up. 3, there's like a nation state attack. Like we shouldn't be able to basically kill the network. And so there's 2 sides of that. One is this kind of permissionless execution, the ability for anybody to run any of the infrastructure. Obviously, everything is open. But the second was this concept of non-sorted enforcement on packet flow, basically to make it so that if you have at the application level, so it's specifically application and pathway level, so let's say Ethereum Solana might be one pathway for a given app, you must validate every transaction in the exact order they were received, or at least they must be executed on the other side. So me as a DVN or as an executor here, I can't arbitrarily say I'm not going to process packets from this group. I'm gonna insert packets at anything like that. Everything must follow non-sorting, which means you basically stop the wheel of time or you process everything.
Probably why you cared so much about.
Yeah, definitely.
It's all coming
identified
together.
with it.
Yeah, very much so. So yeah, at its whole, like that's the problem that we're trying to solve ultimately, is just make communication very seamless. And
we wanted the protocol to be as robust as and as trustworthy from an applications perspective as the chain itself, where they can, once they start building on a library, once they start using it, they don't need, LayerZero labs can't do anything to them in the same way that Vitalik couldn't do anything to people building on Ethereum. Like nobody in this company, nobody in this, and no multi-sig, nothing could jump in and do something bad to your packet. Right. It's the application's in full control of its own security and how that looks.
That resonates a lot. So Solana, this is not the way that all blockchain works, but the way that the Solana network, the validators choose which code they run. There's no pushing to the network other than transactions. So that's just a part of the protocol. But the protocol itself is described by software that they choose to download and then run. And right now, that's just the Solana Labs open GitHub. Some use Jito, some use some other augmentations of that permissionlessly. So it is very much, no entity can push to the network or to do any change to anything. There's processes for governance around economic changes or some protocol breaking changes, but those are voted on and then submitted to the network. And then there's the implicit, just on any minor code update, that the implicit nature of the validators choosing to download and then use it and then actually run the software live on their with their stake. That's like, yeah. So I totally agree. Like, it is really important that is permissionless, and so you have these safeguards as independent entities operating your businesses, or whatever your incentives are. So yeah, I think that resonates a lot.
I think Isaac, our chief architect, always put it pretty succinctly that you need to be able to give developers the ability to reason long-term about liveness and security, right? If they're going to build their entire stack on you, they're whatever this thing that's being built, like if you can't give them the ability to reason about liveness and security, it's very unlikely you're going to get sort of the best protocols building there. If you can, change those things at any time.
Yeah, it resonates a lot, because you hear this thing like users don't care about decentralization, and I actually agree a lot. I mean, users not going to go into like some wallet and then reverse engineer how many like independent entities approved it or whatever. They might have like some group of influencers or whatever they might listen to, but the builder is going to care. They're going to care about their business in a year, 2 years, 5 years. And so that's what matters in terms of the products that are competitive against, whatever centralized systems, is where can I operate my business the way that I want to operate it.
Yep, 100% agree. Yeah. All right, next part is, let's dive in. We had a very long journey. I think from the first time we touched Solana, we said, all right, we're going to create the Solana endpoint, to actually getting it live in production was almost 2 full years. Now, there was like a gap in there where we're like, okay, this is too messy, and then we came back to it with fresh eyes, and Solana had changed a little bit and got out the new implementation, which is live now. But I think I want to hear you talk about kind of what that process was like, what made it difficult, and then just to go into that whiteboard, if we want to whiteboard all of it.
Yeah. So one of the things that we LayerZero does is we very much have this concept that messaging is not just validating and verifying that a packet, but also executing.
Okay.
Right? And so from the application's perspective, when they build on us, when they send a message, they said how much gas how much they're going to spend on the other side to execute, and that part they pay for it on the source, and that part is taken care of from the destination. They don't need to follow up on it. They don't need to have any tracking or anything like that. It's going to automatically execute. Now that works on an EVM because it has this dynamic dispatch where you don't need to know anything about the addresses or the contracts that are going to call each other, like in a call chain, right? You can go, and you guys have dynamic dispatch too, but you require the addresses of every piece of memory you're going to touch.
Yeah, exactly. Yeah.
Where EVM doesn't. It can do it on the fly. The benefits of you guys doing the way you are, where you're making everybody have the addresses, is you can run things in parallel because you can see which addresses conflict.
You can pack blocks without actually having to execute the code, and you can do blocks can be parallelized without having to optimistically confirm. That's like actually one of the biggest difference between like the block STM ecosystem in Solana is like, our blocks can be packed asynchronously and not just optimistically.
Yep. Which is where you guys which is a huge speed gain beyond
huge, I mean, this is the practical like speed, and if you're trying to do it across the speed of light, it's really easy to pass the hash of the packed blocks across. So you can actually asynchronously execute the actual execution because everybody knows what the block ends up having to be. Whatever the result of the actual execution, that is deterministic across all the parties, so that has to be synced too. But the actual block that is being generated, that can be propagated super quick.
Exactly. Which is great from like a chain speed perspective, but from our side, when we're developing this, right, we're abstracting that from the application, and there's a big disconnect between off-chain and the application itself. So it means like the validation is easy because you're validating a bytes payload, right? So you don't need to know anything about memory to do that. You're writing so if you imagine from a perspective of DVNs, they're all verifying on chain that this thing happened, that this is the packet. So cool. There's no requirement for memory there. But on the execution side, for the executor that's going to then execute their program on Solana, that is where things get messy. That would mean that the executor would have to have a relationship, which right now it doesn't, with the application to have its SDK, to know how to call it, and do that for every single one of them. And that means permissionlessly working with LayerZero goes away if you built it that way. If we built it with the concept of, okay, well now you got to go, you can't just send a message to Solana and vice versa. You have to go you have to go talk to an executor
Yeah.
and say, here's the SDK, can you do this?
This is the active state. This is
Yeah.
what you need to touch in order for that message to be executed.
Exactly.
Yeah, yeah.
And we said that was, from our standpoint, that was a non-starter. And so we had to come up with a way to do that without the executor, because we don't want it to, sure, we could do that as labs. Our executor do that, but we wanted this to be scalable to a point where you don't need labs.
Yeah, you don't need end-to-end
anybody.
communication.
Yeah, you can just send the message and it'll execute on the other side. It has to know how to do that. And so what we came up with.
Do you want to whiteboard this and actually walk through?
Yeah, sure.
Yeah, I'm actually really curious because there's some follow-up questions I think I'll have.
Okay, so if we're going from an EVM chain and we have our endpoint, it is, there's a list of DVNs that are listening. So DVN A, B, C, that are selected by the application. So we have the application talking. And they are going to, on the Solana side, and essentially all attesting and saying, packet. So for this original, this packet, this is the hash. And so it's easy.
They don't communicate at all. So they're all independent. There's
each
no
one is
like
independently writing.
networking between them.
Once some threshold is met that's set by the application, it is now the executor's job the executor is going to listen for when this happens because it also heard this packet. And so this is where the hard part comes. So what we decided the design would be is that everybody is going to implement, we call it an LZ receive types. I get all the space. So it's LZ receive is our terminology for how to, the interface you would do to send the packet that comes from the endpoint. Mm-hmm. And we made this extra step type. So we put work on the developer. And the developer essentially, LZ receive types takes the same payload that LZ receive has. So whatever the payload is that would have been executed, so whatever this hash comes to, mm-hmm. and they would then interpret that payload and have some type of switch statement that says, if an opcode is X, these are the addresses you need. Mm-hmm. Opcode Y, addresses you need. And then return those back to the executor. So the executor doesn't need to know anything about that as long as they implement this interface, and then they can call LZ receive permissionlessly.
Can I walk through just from a very high level? My understanding, I may actually have some gaps here. You worked much closer on Solana side, but basically, my understanding is in Ethereum, what's nice about composability is you have some contract here, let's say Uniswap, and Uniswap just exists. It's some immutable piece of code that lives there forever. And now any application that wants to compose this can basically say, I'm going to make call 1 here, and I'm going to do something in Uniswap, and then I'm going to have some other like call 2 here. So this could be a transfer and call. You can transfer and swap. You can do whatever you want. But Uniswap itself, the application never changes, never knows about anything else. In Solana, because of the requirement, in order to make the call on the other side, you need to be able to allocate memory. And so you need to know the addresses of the application that you're calling. If I make Stargate is our sort of canonical example of like a bridge, and what you want to do is transfer and swap, transfer and deposit in the staking protocol and do something. If Stargate is immutable, then it doesn't know the things like you want Stargate to be able to exist and not know anything about any of the applications composing it. In the Solana structure, if I have this thing that is immutable that lives there, it cannot make the call on the other side because it doesn't know about it. Now, is that at the application side or is it the executor side that needs?
So only difference here, you're just passing in a list of addresses, right? And these go in to Uniswap. The Uniswap's just going to keep passing the addresses that are required for it. If you didn't know the addresses for this application, it'll fail. So what happens is Uniswap would then make an SDK, or the application that's composing Uniswap, right? So it's actually usually something that's built on top, would make an SDK that includes the Uniswap addresses and anything that calls after it, plus whatever is itself. So that means that all the off-chain infrastructure, every executor needs the SDK for every application it interacts with, which is basically, that's the communication error is the problem. Yeah. But if every one of these in the call tree implements an LZ receive types, they can all call each other and then send back all the addresses to the executor, so it doesn't have to know anything about it. And so that's kind of what we're going for here. Does it make sense?
Yeah, I guess the thing. The first question. So when you're creating these, the developer themselves
Have to build that.
Has to build that. Okay.
So we put more work on the developer so that it doesn't have to communicate with the executor. It doesn't have to communicate with off-chain infrastructure. It doesn't have to make new relationships.
Yeah, so developer that I am building a cross-chain app or some sort of cross-chain standard, I have to describe on the Solana side all of the potential addresses that are going to touch
based on the payload.
Yeah, based on the payload. Right.
If
it's this payload, or if I'm doing this type of swap that touches this pool, I then have to name all the addresses of those pools.
Exactly.
Yeah. Okay.
And then it just returns those. And so then by doing that, we save, we protect that the way the executor works and that very permissionless side. Where from the app standpoint, anybody who's an executor for Solana, they don't need to know about or talk to. They can build everything on both sides and permissionlessly communicate with each other and execute, which is not something that is done by any messaging protocol that currently interacts with Solana today.
That's really so. Okay, I have a one step higher. That who owns the SOL? Is it these DVNs that are paying?
So each DVN, every off-chain infrastructure has gas on every side.
Okay.
And so they're basically quoting on-chain. So on both sides, we're quoting on-chain, and the application will basically do a view function and say, "Hey, what's the quote?" It'll then check what the on-chain quotes are. It will then submit. So on this side and the SOL side, it'll submit the SOL to pay them to execute on Ethereum. And they're basically paying in SOL at a price and that they have an on-chain price.
On-chain quoting. This is the price of Ethereum in units of SOL.
Yeah, for how much gas you want to use.
Yeah, exactly.
And then it'll go and execute that for you on the side. So they have it in their wallet, they're executing.
So they could basically a DVN will say, "I'm willing to do it for this price, whatever," and there's some quote on the sender side.
Yeah.
Okay.
Yep.
So everything's done and executed on the sender side. Once you send a LayerZero message, it's set and forget kind of thing.
Yeah. So if I quote and end up being a lower priority fee or whatever on the Solana side, I can just make a few bips from that. But if it ends up being higher, I've already committed
Sometimes,
to.
So typically what they're
There's
doing
some
is
sort of
taking
risk-adjusted.
destination, what you're accounting for is basically like vol and duration risk, right? For the amount of time that you have for finality. So like out of ETH, a lot of times it's 15 block comps, it's like 3 minutes and 15 seconds. You have like 3 minutes and 15 seconds of like vol and duration risk on prices and on priority fee on the destination chain. So they're typically quoting destination gas plus 3 to 5% roughly.
Okay.
You lose sometimes, you win sometimes, but on average you make about that spread.
Sure. Okay. Yeah, I like that. So the things that part of the reason I'm thinking about this is because on Solana, the part of the reason, another thing about the naming of the accounts when you go in, the fees are actually per account, or at least they're trending more and more that way. There is just a just flat priority fee, but there's also a local priority fee that is local to individual pieces of hot accounts, and they can both vary. Now it's represented in one fee to the user, but there is basically a harder necessarily to predict if you are. So basically, if any of these pools are touched that are contentious, which there probably are if you're going to do some sort of swap, you might run into that. So there's some level of prediction in there that a good DVN would.
So the DVNs are abstracted from that. They don't have to think about that because they're just submitting the hash. They're not interacting with this. The executor is the one that has the most risk.
Oh, okay.
And so the executor is the one that's going to have to monitor the variation in pricing and adjust the pricing on the other side.
Okay.
It's very interesting though. So, obviously there's a lot of, I've done a lot of thinking, just us in general, on like the EVL parallelization efforts, right? Which obviously are sort of the constraint in parallelizing the VM is you can parallelize anything that doesn't touch the same state, but anything that touches the same state you have to serialize. So I've actually, I find it very interesting to have independent pricing on specific pieces of state that are hot rather than sort of across the entire network. I think it's a very cool mechanism.
Yeah. That's like the fundamental part of the design. I mean, there's a lot of little nuances to each part of that. Like even things like I'm actively making a block. I now observe a new incoming transaction that touches pieces of state that were already allocated to two different threads. So say you just have a couple of sends with a token to a pool or whatever, they're just starting to provide liquidity. I put those in two different threads. Well, now somebody's making a swap between those pools. I cannot do that because there's transactions already allocated to independent threads. So that transaction has to go into the next block. So there's a bunch of like little nuances because that becomes a really complex problem in practice. And so we actually expect both there to be a lot more dynamic fee structures, but also there to be kind of a, I guess, block packing is going to be a whole like cottage industry that people can, but it'll execute a lot differently than the Ethereum world. So the Ethereum world tends to, at least on
page.
Yeah, maybe, sure. This is my understanding. I'm not a super expert on Ethereum block packing, but like, you know, especially on mainnet, you have, or I'll do, oh, that's cool. Intuitive design.
Yeah, nice.
On mainnet, you know, you have like a, whatever, 17-second block. But the actual computation time is just like a fraction of that. So, and there's this issue where people tend to wait till the very end to actually submit, and in that time that it's like dead zone right here, that is when they're like looking through the mempool and searching for the maximum profit block here. So oftentimes they will outsource this to get the maximal. They'll outsource it to some other thing, and then they submit it near the end. Whereas you can't really do that on Solana because you're filling basically to the maximal of that 400 like when you have a 400 millisecond block. Obviously, you can. And there's no mempool to draw from. You're receiving transactions, and so you're just processing as they come. So you have visibility of just, you know, the set of transactions coming in, and it's much harder to backload.
The network
that.
latency is so costly that you have to do it locally, which means the cottage industry will sell software, right?
Exactly. It'll be like a sidecar process, exactly. And so that's the way that the protocols are being run differently. Whereas this is some sort of like API pass back and forth, or even just like some sort of like delegated signing. Where in Solana world, it is going to be a sidecar process that you put, just like Jito is right now a sidecar processor with a relayer that handles tips and just, you know, like that top level ingest. This will just be, you know, you have the SVM that sits here, and then you have some side level process right here that just like feeds it. It'll feed it per shred too, because it has to be quick. That's the thing. So it's going to level it. It's going to start here. It's going to feed it that shred, and then the next shred, and then the next shred in sequence. But it's going to, you know, the business will have to show that like, oh, my algorithm works much better than these other algorithms, and you know, there's probably going to be something that inserts some price feeds and other things in there to help predict which shreds they have.
400 milliseconds is a lot of time if it's local. Do you guys imagine it'll be like a market co-located?
But the thing is, they have to be producing shreds actively for the proof of history ticks, and that's the totality of. So I forget the exact number, but your block is made up of a bunch of individual shreds that you have to be propagating to the network, or else the network will think that you're delinquent.
Yeah.
So you have to be producing this, and if it's empty because you're kind of delaying it, that doesn't give you anything because that has an allotment of compute.
So within a block, there is
so you have to. There is a time ordering. Like you cannot wait. You have to be packing this if you're trying to profit maximize. Unless you're taking some weird like expectation that there's some really high value sandwich later or something really, really, really complex. Otherwise, you're just gonna be producing blocks as fast as possible.
What's the latency requirement? Like, how long of a timeout before they say you're not producing blocks, you're done?
That is a good question. I think as long as you just miss the block time. So it's like
you have the 400 millisecond window. You're saying during that 400 millisecond window, you need to be giving ticks. You can't do it in one chunk at the end.
Yeah, exactly. That's quite literally, yeah.
Okay.
Yeah.
Yeah. Okay, that makes sense. So then it has to be their own process, or on really fast co-located machines that are bidding. You don't think that's possible though?
You're actually, there can be a co-located auction, basically.
You could have some, I think you can do some, maybe that with some understanding that there's going to be some jitter latency in that you have to do some sort of risk adjusted thing.
Okay.
Sure.
No, it's cool. It's really cool.
Yeah.
Cool. All right. Now we're going to dive into, we spent the last, 2 years, but let's say the last six months, like really going through, just thoughts on having built through the SVM, having like endpoint is shipped now, like, what did you come away with architecture-wise? What you like, not like? Do you have any strong opinions on anything? I thought it was good to just talk through, have a technical discussion.
I thought that in terms of building, I think one of the things I don't like that it's just more of an opinion on thing is that the requirement of SDKs versus like being able to interact with the contract directly without knowing how it works is a cool feature of EVM that I felt myself. That's why we built that part. We felt ourselves missing it. But I think that was one of the hardest parts to deal with.
Mostly because we were trying to keep feature parity, right? Because we already have the system that is, at the time that Solana went live, it was 133 messages and tens of billions of dollars of applications built.
And I think even more so if I started with Solana. Like there's a world where we started building on Solana first instead of Ethereum, that we would have wanted that. We wanted to deliver the full flow of making it feel like a TCP/IP packet. When you send the packet on the internet, the packet delivers and executes on the other side.
Yeah, you don't have to have a knowledge of the actual architecture.
Yeah, you don't need to log into the other server to make sure it's served up.
Yeah, exactly. Yeah.
And we wanted that experience if we're building this internet. And so it would be something that we would never really compromise on. And I had talked, I can't remember his name, but one of your engineers a couple of years back about this. And one of the things I think you guys could have done and still can do is having an extra layer that given a function call, you guys could run through a simulation and find out where it breaks every time and then give back the addresses. So that the developers don't have to build this and that we don't have to build, because we're putting a lot on the developers. Now we're saying you need to think about this stuff so that you don't have to have this communication layer, which is, I think, a worthy trade-off. But even better would be to have that layer that's outside of running, outside of the protocol itself, that could either an extra layer on top that generates the address for you and then submits the transaction with that atomically. So you do that, hit the next part, generates it and puts it in. I think that would lead to a better user experience and require less coordination between applications themselves that are building on each other and their users.
This is good feedback. I think right now we have a pre-flight check or just some basic error handling that we're actively trying to improve because exactly a lot of this reason. There's two things that I know of that are relevant. One is stronger typing, so you can know the underlying instruction set and the types, so that creates much easier CPI, like a cross-program invocation, so the composability across, if you know exactly which types and the expectations of each functional programming call. So that's something like Move does that out of the box, for instance. And we are trying to put that in protocol, so still within Rust, but the SVM protocol enforcing those things. It would take, we're loosely calling it runtime V2, but it will conclude some of those features. But yeah, being able to do more granular error cases and makes sense.
Oh yeah, I think that the protocol is certainly not built in a space where it can't do that. I think it's just early, and you guys will have that in the same time.
This goes back to like the kind of the practical nature of shipping something, making sure that people love it and use it, and then helping your users find out the possible details. So I can imagine like a whole set of features that from inception, that if you just build that thing, it's like the perfect experience. But oftentimes, if you're off just enough, it actually destroys the whole thing. That's a classic like product making. Yeah. So we chose to just be, partly for financial reasons. Solana released in like March of April of 2020, like right as the world was about to, potentially go into some cataclysmic recession because of COVID. So there was some level of just like needing to ship and get people to use it before, risk adjusted, like, are we gonna have enough runway, and this thing needs to go live and start doing it. So there's a saying within within the Solana ecosystem, like the wrong decisions, but at the right time. And the idea is like that it actually informed a lot of the future growth. It just, that's where like Solana development started off as chewing glass, is because of that environment where things released kind of flexibly and kind of bare bones. And now we're adding these things over time. That's kind of
that makes total sense. And then the other thing. This is not necessarily Solana's problem. This is more of a little fear from the industry of how everybody makes everything upgradable, and so or most people do. And like core infrastructure, like for example, Token 2022 is owned by I think, what the development firm.
The labs
Not
originally,
Labs, right? It's-
right, labs originally make it. Anza is
Anza
now
owns
the
Yeah.
and it's going through formal verification right now. And if that goes well, we'll do what's called like a security lock on it, and so it'll be effectively locked in a multi-sig with multiple parties and then some security firms. So it'll only be upgradable in the case of some sort of security incident.
Sure. But SPL was built ingrained into the protocol itself before, right? So that was never owned by anybody.
Well, SPL. So there's different levels. So there's native programs, and those are in protocol.
Yeah.
Like those are, and actually those are being actually just translated to raw BPF, so that FireDancer and other things can just make more generic code. The SPL is built in runtime, and that one is locked. So that one, it
Requires a fork.
No, it's just locked. So it is immutable.
Yeah.
So it's not, but it's a little bit. It's not in protocol. It's just like any other program, but the programs themselves have a unlocked and locked state.
Yeah.
So it's just an unlocked state now.
Okay.
Yeah. So that is fully immutable.
Yeah. So I think that the fear is of those things is when they're mutable, there is that fear of security breach on whoever has the keys, and that being, even though it's a token standard and it's being core, that being, I guess, rugged not by you but by like a hacker or something like that,
Sure,
right? And
sure.
So like our stance when we did OFT was that we don't really want to expose the factory, and we want, even though it will cost a lot of money, we think it's worthwhile from a security perspective and application to deploy their own OFT directly versus use one that generates from our factory. Okay. And that way they have full control. Now that risk, the trade-off is if there was a problem, they would have to fix it themselves, or they take a code fix from us and do their own upgrade. But it removes us from the equation and
so on the Solana side, you generate a new program ID every time. Okay.
Yeah, every time for each program. But since they all have the same universal interface, right, where they have that LZ, the part that says "give me the type," you don't need to have a new SDK for each one.
Yeah. You don't need a new SDK, but that is a little bit different than the normal paradigm on Solana. This is something I've been talking to some of the BD people about. Like it's just an adoption thing. Like just keeping a list of anything that meets that standard. We actually have interfaces project that we are working on that will help you with this. Like once something just meets that spec, then it just gets included in the standard. Like if it has all the right methods and meets the spec basically, then you can more easily just insert that program ID and it works.
So I think 99% of the world is going to have way less context on Solana than the two of you. Can we whiteboard this part as well and just explain the differences? Like, okay, here's how it works on EVM, here's how it works on Solana, here's how we built our implementation on Solana, and what,
Yeah, so...
I think there's another pen here.
Yeah, cool. Basically, we're talking about the way, there's some smart contract code, and the way it's written in a certain way, how does it go into another one, or if there's just different versions. So, or how do I say it? Okay, so in Solana, programs are stateless, and this is you can think of this as a .exe. It just runs code. It doesn't have anything. If you were to put any sort of data, say this is some sort of decentralized ID, and I wanted to put stuff about me, I would actually create another account that is owned by this program that describes me. My name is Matt. I work for Solana Foundation. Whatever, and then this program would govern that information. But anybody else could submit their own, whatever rules that's been defined as the program, to submit their own ID. I don't have to redeploy another program for Bryan or whoever else to put it. That it's all just
they'll use that code.
Use that code.
Yeah.
What you're describing is that's a little bit different than the EVM world. In the EVM world, everything is packaged in what's essentially a class where you have all the methods and the data in one place. So you have so these are all functions, like function 1, function 2. So in the EVM world, the data of like Matt Sorg and all that stuff will be in some data object, and then all the functions will be in one, just in the class that describes this. And then you just known that if Bryan was to create one too, he would have his own contract, and they would follow some sort of ERC standard that has a spec. It has some data of some format. It has function 1, function 2 that are described in a specific way, and that would be the same thing with Bryan's contract. Or that would be the DID, whatever. But yeah, in Solana it works this way, where you have the one program that kind of defines things. And you can have different programs do very similar things. Yep. So there is some crossover there. There's multiple NFT programs that do follow the similar spec, but for basically Metaplex NFTs, for example, there's mostly just one program that describes all that is owned by them, that describes all NFTs of that type. Now, CNFTs is a little bit different, or there's a new one called Core. There's a 404 standard. There's a bunch of other things that are all independent programs. But if you're making a one-of-one Metaplex NFT, you're just making copies of the, Metaplex whatever 2, Metaplex 10,000, whatever. So what you're describing is for, maybe you can take it away at some point, but like LayerZero, you're making it so you don't do this, I would call like the semi-standard way of doing it on Solana. You're having people deploy the program.
But we tell you not to.
We
think you shouldn't.
Can I explain like my, I'll take the layperson's, here's the sort of lay understanding of how everything works. You can say where I'm wrong on Solana, you can say how we did it. But let's lay understanding is, on Ethereum you have, let's say ERC20 that exists. This is some standard for a way to issue tokens, and then you have a bunch of tokens that all get built, basically just forking the standard and adding in their own data, whatever that is, right? And so this might be like, great, it's uni, and it's X, and it's Y. It's everybody has their own token. Each one of these owns this individual contract. Each one of them typically is immutable, but they can be upgradable. They can kind of do whatever they want here, but let's say these are all immutable, and there's nothing that can happen here at this level that can affect any of them. If they make it upgradable, they can change it and they can do things. And so this is coming from EVM land. This was kind of like our sort of norm of expectation is every project owns this own thing. They're they can take the standard, they can add things to it. If they break it, that's on them. But they sort of have full control over this. And then when you come to Solana, like you said, SPL is sort of this way. SPL is locked in a way, but we'll say token 2022. You now have a program that's here that defines everything, and then you have a bunch of people who create instances like we were describing over here, basically of this, and we say, this is X and Y. This is token 1 and 2.
D is one example,
Yep, exactly. And so the difference is, in my understanding, is this contract here, where ERC20 is not owned by anybody. This contract here is owned, and if this is unlocked or upgradable, then somebody can change this, which will have downstream implications on these two. Now that means they can fix this and they can add things to it and make it better and do all kinds of things, but fundamentally the difference between the two is X and Y are in some way reliant on this, and Ryan's overall concern is that the owner of this now becomes a broad risk to all, so this gets a ton of adoption and everybody's using this standard. There becomes a massive pool of risk and the ownership level of this, and you can turn that into you do a bunch of things to pare that down, but that is my understanding of the structure. And so if that's right, you should talk about how we did it and the trade-offs of that.
Yeah, it's like I'd said, I have been, you can come. It is exactly this one-to-one nature. Now, because the way Solana works, anybody could, if someone else deploys, to say Uniswap deployed this or somebody and did their own, there's nothing to prevent somebody else saying, I like this program.
Yeah, exactly.
Uniswap promoting it, I'm going to do it. So it still has the same properties in that someone could do that. Our recommendation in our tooling has them do this. Because we want them to, just like whether this is upgradable or not, so this token could be upgradable, it is in control and owned by whoever made X. And we want that to be the same, we want to have the same security properties here, because from like, hackers, state actors, like it is one central point of failure for every single token that uses token 2022 on Solana.
Yeah.
So just to be clear, when you're highlighting this and saying this, what we're saying is, okay, here's OFT on Solana, and here's some implementation of that. So let's say that's 0 or whatever. And if Uniswap wants to do it or somebody else wants to do it, we want them to fork this and make their own,
deploy their own code
contract 2 that has their own subscribed thing that is their token X.
But it puts them in a position where they could make this immutable or they can make it upgradable, but they're now in full control. There's nothing that LayerZero Labs can do to OFT or a multisig could do to affect their token.
Right, so then from an application, so the challenge here in the Solana ecosystem is a lot of things are used to this way. They're used, like a wallet, for instance, is used to looking at, the token 2022, the NFTs, the fungible tokens, and just doing, let's say, a suite of 20 various token types across NFTs and fungible tokens. This potentially would create hundreds, thousands, hopefully for you guys, tens of thousands.
OFT works differently in that we don't touch the tokens there. So this could be any token. This could be token 2022, or it could be SPL, right?
Yeah, exactly.
It has the mint and burn authority, and this part is owned by the app.
Yeah.
So if the app wants to inherit token 2022 risk of what I'm talking about, where it could get upgraded and have side effects to them, they could. They could also do it. They could deploy their own token 22. But what we're telling them is, don't depend on labs for the OFT.
Yeah, exactly.
So we're making this opinion stance only affects people who want to use bridging. So Stargate, any bridge aggregators, this will matter to them. For within Solana itself, has no impact because everybody's using token. So whether they're using SPL or token 2022 or any other variant that you come up with in the future, that won't impact the OFT part, or this is just the messaging part.
So this part is just the part that communicates with the bridge.
Yep, it just communicates with the messaging side.
So you wouldn't necessarily, okay. So my original thought was that DeFi would care, but you're still interacting with this is sufficiently that DeFi is okay. So you just have, if somebody wanted to create like some other bridging layer or something else on top of your protocol permissionlessly, like obviously Stargate is a bridge, but if somebody wanted to do something else that interacted with OFT itself, that's what would be potentially affected. If somebody was...
So OFT goes directly to the LayerZero endpoint, right?
Yeah. Oh, okay.
And so this OFT is just a standard. You could make any variant of your own like token messaging, but this is what OFT is. These are the interfaces for how you interact with it. And why does that matter? It matters for a bridge to be able to integrate any OFT by knowing the interfaces that it has LZ, receive type, and all those types of things. So it can, not without knowing anything about it and not having an SDK, list all of the tokens that are bridges and not have to have any information. That are bridgeable.
Okay. Yeah.
That's what the OFT standard achieves. But anybody else could go about it any way they want. It's a bytes payload packet, so you could build whatever any standards you want. That was the opinion-based stance we took without that we think it doesn't affect with anything that happens within Solana.
Yeah.
So.
Yeah. Like.
Cool.
All right. Whiteboarding's the best. I love it.
Okay, so one other thing that I think you guys probably get this a lot is stack depth. So like right now it's 4. That becomes a bigger problem for us in messaging, and because you have to go through a messaging library and then an endpoint and then the application built on top. So there's not many more layers in terms of composability via messaging that we can achieve. You basically just get one more hop before it requires a second transaction. So I think like that's the only other thing that really stood out. I was like, oh man, it doesn't stop messaging, and it certainly makes like point-to-point, endpoint, application seamless, totally fine. It's when you want to start getting deeper. So you can see that with like Stargate, things that build on top of Stargate currently, a 4-level stack depth, it'll start to feel the pain. Where
they're going to transfer and deposit into their protocol one thing. Just one-click deposit from Ethereum into this application on Solana.
Yeah, there's a couple things there. So there's stack depth, and then there's the payload size. I actually think they're pretty similar. So right now, Solana is optimized for one individual packet. All the information just needs to be included in that singular payload, and that's just a efficiency thing. It's a performance thing because the protocol expects, all the information I need to run this single transaction is baked into this one message that I'm receiving. That actually, there's very clear plans to change that and increase it so you can actually have multiple packets describe one transaction, and then that will allow us to have more. There's more reason to include more, stack that and allow for more complex transactions to happen. I think there's a little bit of context too. The main reason why that hasn't happened yet is because that is very clearly like a consensus breaking change. You can't have part of the protocol making larger transactions than the rest are able to process. The fired answer is essentially like a loose pin on the spec of Solana until fired answer ships, so that fired answer doesn't have to keep on battling against the moving target. So there's actually a decent amount of backlog of things like cryptographic curve functions, like the BLS 128. Then several of these like transaction types that but what's nice is that those will be across multiple client implementations when they start rolling out. So all these things are very much in the roadmap.
Sweet. Very much looking forward to that. It'd be awesome. One other thing was you had said that token 2022 you guys were planning on locking that, but it seemed like from our side when we were looking at like the developer roadmap and all the things, you guys had it kind of open-ended because you have like the hooks, you have the ability to like do this like where you can do blacklisting. Like the reason why it seemed that token 2022 was created was for those tokens that are very permissioned and have like special rules and things they want to do, which make total sense. From the CeFi side of things. Now, how, I guess, do you guys feel like that's finalized and you will not be adding to that? And like, will there be a token 2024 that comes next?
Yes, So the idea, so there's a couple things here. The code at which executes the transfer hooks. Transfer hook is essentially a callback that knows that something is going to happen. Some executional logic has to be performed. The token 22 part of that can be immutable, but the function that the developer chooses to create their conditional logic, that's up to their purview, and that can be whatever that. So individual tokens may have mutable parts, even if token 2022 itself is immutable, and that's going through the formal verification process right now.
Okay.
So that once token 22 and all of it, which is rebranded as token extensions, you can tell he's OG by calling it token 2022. But yeah, so token extensions are in formal verification right now. They'll be put into a security multi-sig for some period of time. It's just that's like a rollout period into immutability. It'll be made immutable, and then any other like kind of program level standards that are added on will go into a completely new version. I think we will stray away from calling them year numbers anymore. But there'll probably be some sort of like extensions and then maybe some named thing that describes that feature set in some way.
Who does formal verification on Solana? Is it?
There's a few. OtterSec has a few live programs. I believe they've done. Squads, the multi-sig, because that's obviously it's a relatively simple but very high asset ownership program. Token itself, the SPL token. There's a couple more that and then Certora, and has one, and there's a couple more that I apologize to all of the great auditors that I am missing out on. But those are the two that I know of.
Cool.
And one of the things we discussed back in the pit back there is the like risk surfaces that are introduced with like the transaction hooks and all that, where and if someone could create a malicious token that gets traded constantly and swap out the I guess that transaction hook gets compromised, so it becomes malicious, and now breaks some dexes or anything like that because it's unexpected behavior, right? Because they've built their whole code around that and create some type of DDoS or weird outcome where maybe they think they got a token transfer happen when it didn't or something like that. I guess what have you guys been thinking in terms of like I'm sure that those things came up when you said, let's make these
Yeah.
cool features.
There's some risk of that even in like the ERC world, where there's a standard behavior, but then there's some off behavior that you could inject into that happens with like it can meet the spec and have it run through and have all the methods that perform, but there could be some conditional on something that does break them, right? And so there is that risk almost on any paradigm you choose of somebody inserting something. Like you actually see it today, even on existing, where they'll wrap it in something that makes it so you actually can't trade it or it burns on trade. It's like the diamond hands tokens or something really stupid. Like, and they look like they have like really high value because the initial minter will like do one transaction at some ridiculous valuation, but then no one else can trade ever to trade it down. So that somebody will look like they have like trillions of dollars in their wallet at some point, and those are obviously just scams. And because all the only revenue is just the mint revenue that people are initially minting as, and so I think there's risks all over the place. I think a lot of what you're talking about actually depends on which part of the stack has to handle that. There's like the consumer layer, what is being shown to them, like if they're being sold something that doesn't have a transfer function or it doesn't perform to a certain spec, like that should be shown. So something like with token extensions, for example, you probably should show them which extensions are enabled or not in some UI. Like even if you're just getting one that has a whitelist or a block list like attached to it, you'd want the user to have some level of knowledge that they can only use that within some permissioned ecosystem. So I think some of it is on the application layer, like the client layer, the wallets, the RPCs, to kind of expose what's there, which I think one of the burdens that Token 22 currently, or token extensions currently have, is that, like adoption across all the ecosystem in a way that each individual partner knows how to expose whatever that information is. So there's that like kind of, I don't know, the UX of it, the feel of it, which is a type of security, And then there's the other one, just like more functional. I think the program itself is pretty flexible in what it expects back. It just expects approvals and denials of certain things, and some of them are more flexible than others. And so I think that's implicit. Most things just choose simplicity, like not to be too opinionated on. So then you force the other parts of the stack to whatever you care about. You have to make sure that those assurances exist within that other part of the code. And so you can make things like, the way it typically happens is that piece of code needs to describe to you. So it must release its SDK in order for, if it doesn't have an SDK, my DeFi application won't list it on its front end or whatever. So that's kind of the way that the ecosystem self-polices today.
Got it. So one of the things like in the ERC world, like ERC20 hasn't changed, right? There's things about it that would change if they could, but it has so much stickiness and traction to it that everybody will build things on top of it and build things inside it, but wrap it or put it. But they're putting that into the contract itself. But you guys went the route of with token extensions. I'm gonna start using that to basically have the base program, which is the token extensions that is owned by you guys or by the soon to be a multi-sig, but that'll eventually become immutable. That then has this mutable portion that the applications could add to it versus them. But they could have, if they wanted to, kept the original standard and built that into their own program, right? You're doing this because you want them to share the universal program from the token extension standpoint.
Let me see if I can describe the question back. So like there's one world where you just have some very, very simple ERC20 base. You could actually just done this on top of SPL token, where you just expect some wrappers to exist out in the world that will add this extra functionality. Why make extensions explicitly? That is a good question. That is actually something that was a bit of a debate. You can actually technically think of token extensions as a semi-wrapper, because the base functionality of token SPL token, like that, most meme coins are today, that is byte-wise equivalent to the base extensions. So if you don't enable any extensions, it's essentially a token, SPL token. And so it is, in that sense, it's not explicitly a wrapper. It is a unique program ID that is a complete different code set. And that is mostly for usability. Like it's an adoption thing. There's always this trade-off of like how ease of use across an ecosystem, and then how do you actually get adoption of something versus flexibility when you have, it's like XKCD if you add like a bunch of other standards, and like then you just have these other standards, and so you get like an aggregating standard, you get some other standard, and so the extensions is to have just the one program ID, a bunch of options and configuration options for stuff that we found to be pretty standard. So that has more likelihood of adoption than a bunch of different program IDs that do some subset of those things in disjoint program IDs, where that you expect the applications to keep track of all of the program IDs and all the individual extension subsets. Because I've already described, like I already think that the biggest risk to adoption is the UI layers being able to display all this, and if you add on to the underlying complexity of what the things even do, so you're trying to communicate this to the user that this is a token of this type and it has this subset, that becomes dimensionality like really, really hard as it blows up in the number of token types and the number of other things that are there, and how to put the UI layer on that. So that is basically just thinking all the way through it, because we're both platforms. Like I think we both have are beholden to both developers building on top of us and like just doing really awesome things, but also appealing to some end user. We don't directly connect to the end user typically. I don't know if you guys do really, but like we don't obviously.
Same.
Specifically,
we're in the same.
Yeah. So, but you still have to think backwards from like what the end user experience is going to be like, and how do you set up the businesses building on top of your platform up for success? And
this is why we cared so much about end-to-end execution. Is we always wanted like the end user should click one time, never think about gas on destination, never need to like change wallet, sign another transaction. So for sure, very much aligned there.
Yeah.
And then if you guys do this extensions and then do extensions too, you're essentially putting, the problem I have with it is that you're forcing the applications essentially to always be upgradable, right? They're always going to be in upgradable state, because if they want to ever accept new token types, new tokens, new standards that come out, they will need to modify their code, likely their source code.
Yeah, actually that is a good point, because you basically what you're describing is, well, maybe. It depends on if you want to add in the new functionality of the thing, then yes.
Well, some of it's mandatory, right? Like a blacklist hook or all that stuff.
It depends on what you consider. Like the ability to add in, like the executable can be immutable. You can just add in a token type that you accept in a mutable data payload. So like this is actually the same thing. Like just like if I'm a DeFi application, I want to set up a bunch of different pools. As long as I can set up a pool for a new token type, as long as it conforms to all the things, I just have to add that program ID, accepting the transfer, all the instruction set that I expect. As long as it doesn't depart from that, it should work. You just have to, because you don't have to depending on the way that you just have to know when you're programming that list of programs that satisfy that spec is going to grow. It's a little bit different than ERC, where you're doing almost the other way, where you're just saying call this function, and if that function it meets those functions, then it works. It is a little bit different. But it still is possible to extend to different program types as long as they meet it.
And the interface doesn't change.
The interface, the core executable is exactly the same, just the approval list would be the immutable part. That would be like, you would call, so basically say like my DeFi swap protocol would have all of the pools, and like it would just have a list of programs, token program IDs that are allowed to make pools off of it. And it would just route through those program IDs into the different, and you just create pools off that, and you would just need transfer functions and whatever the normal functions that a token would expect. And so you could add on new token types if they met that spec. But it does take some foresight to know that there will be new program IDs to add, and then to add that functionality on top of it. So, and then you would need some assurances that you wouldn't be able to delete them to like just rug all of the So that's that's the same thing with the Ethereum world too. You can have this because you can't have every single piece of be immutable, or you should never be able to add a new token, for example. You need to have something in there that has some flexibility.
Yeah, I think that's what ends up happening is that people who want to add new features in the Ethereum world have to work around the ERC20 standard to make sure that, like, if it's a rebasing token, they have to make a wrapper for it. And that's the thing that gets put in there versus
So you do some sort of like
saying,
unwrap wrap. Yeah, the paradigm when you come out.
Versus Uniswap saying, oh, like this new thing came out, now we need a new version of Uniswap, or I got to upgrade the smart contract, which is
that same paradigm works today. If you do swaps on like or a lot of the swaps, especially with like native Sol, they'll just wrap it and then unwrap it. And you can do that same thing with.
So like wrap it into an SPL and then put it in.
Yeah, WSOL. Like just the same way like wrapped ETH.
Yeah.
Oftentimes it gets used in things to get used like an ERC20.
And I haven't looked. Do you guys find that the adoption of the token extensions is growing, or people are still using issuing SPLs?
The meme economy still runs on SPL token, but most of the new, what I'll call like business operations, so PyUSD and some of like the bigger efforts that have some specific functionality, they'll take I mean, it is extra work to program a conditional transfer hook, a callback or whatever you might want to do. So that is mostly larger businesses that are thinking about some larger strategy.
And do you envision that maybe that's what, is token extensions really for those larger businesses, and that DeFi is going to use SPL, or do you want, you personally, I guess I can't, you're not speaking for Solana, do you want people to move to token extensions? Do you want that to become the ERC20?
No, I mean, I think as long as people are operating their business and trying to appeal to it, they know what their customer is. Some customers don't really want a bunch of extra stuff. They want just a permissionless token that represents some whatever to them.
Sure.
They don't need privacy or conditional transfer or any of the number of extensions that exist. I think some of them are really neat. So like you could have some game token that does some really interesting thing, or some delegation that happens that, whatever, for some DAO structure. There's a lot of really interesting things you can do with extensions, but there's no reason to add complexity just for the sake of it. There's actually some of the initial adoption of extensions was just kind of like infrastructure as memes, where they would do something kind of creative. Serves no actual functional purpose outside of that kind of creative thing that you could make a front end for. Mm-hmm. But yeah, so I don't know. I'm not somebody who just wants to dig a hole just to fill it with something and just create entertainment off that. That's gimmicky and not long term. So I think that whatever business is trying to run should be thinking about solving some user problem, not necessarily, and like whatever the best token type to solve that would be. I mean, I guess my hope for this, like especially as we come out with interfaces, which is more like the ERC standards and stuff, is that I do want there to be more diversity in types, and so that we already have more. The Metaplex itself has come out with more NFT types. There's independent token types. So like even ZK compression has its own token types within that decompress into SPL token types or extension types. So there is a broader ecosystem of types coming out, and so I kind of want to make sure that happens seamlessly, so there's not extra complexity to all the integrators and like the wallets and the DeFi and all this other stuff. So that I care more about that exploration being possible than any individual app, which subset of those get adopted, because actually this may be an ethos thing. Like I'm not like emotionally attached to almost anything we ship. Like if Firedancer ships and it just never gets adoption, but the ecosystem keeps flourishing, like cool, whatever. I mean, like kind of sucks in some ways, but like we're gonna ship 10,000 things over the next 5 years, and 20% of them will work in a good 5 years. So that's fine. That's just the way that I think these things evolve.
One more thing I was going to ask was, we one of the things we struggled with was when deploying and like interacting with Solana itself. We've got a lot of like rejections dealing with public nodes and things like that. And
yes.
We found that like we had to use our own private one to do that. But my thought when doing this was, how does this scale? Like, how do users have a good experience? Is it only people who can afford a private node, or apps who are willing to pay for that to expose that to their users that'll have that Like, because once we go into a private node, great experience.
Yeah.
It's how do you expose that to the general public?
This is a really good question. So this is something that this is like access patterns are going to be an active point of discussion. Like, how do you do fees? And there's actually you're hitting a very active discussion. So I think there's a couple different types. One is like the program deploy. There are a few front ends for that have just kind of created their own endpoints that are outside of. Oh, maybe I'll back up a little bit. Solana has like Solana Labs just hosts some public endpoints that there's not really much tooling around it. They don't have stake attached to it or a bunch of the things that are the underpinning of the Solana network. It's just some really dumb thing. It just kind of like raw sends, and those can fail for sure a lot. And you might use them to practice to see if you just get a ping back or whatever. But they're certainly not intended for any sort of production use case, which makes it really hard if you're trying to send a program of any sort of complexity, because as I said earlier, you have to actually sequence transactions in order to create a large enough payload in order to ship a whole program. And so you kind of want something that has some reliability, or else it'll take forever, or it'll fail, or all these problems. And so a few of the RPCs so you're always going to have to pay something, right? Like you just Sol or something. And so some of those things are just going to cost more than others today through, I think one of the main goals is to make sure that ecosystem of any of those providers is diverse enough that it's a competitive marketplace. And that'll just flush out to whatever price that costs. I think there's the other avenue where how discernible that is. There's some I think there's some elegance in the system that we have today. So right now there's a fee that you pay, which is like a allocation fee plus a priority fee, which is just to the user that sends it, it's just a fee. But the main thing that's semi-hidden is that transactions that go through a stake-weighted validator are prioritized, or they basically have dedicated channels to the leader that others don't. And that's for a multitude of reasons. But the idea is that or if you're running your own node, like the sends have a prioritization to them, and that's to anti-spam mechanism essentially. It's easier for the leaders to block spammers or just any transactions that doesn't see as valuable, and that it can be hidden to just like a normal user, especially if you're trying to use just like a public endpoint that is just dummy sending. That's something I think is evolving over time. There's some worldview where you should just be able to handle it entirely through like one raw fee and not have to worry about what infrastructure you send it to, which I actually side more towards that. So it's just basically the balance, like how much of because there are allocations for both of these things on the validator protocol side. But honestly, a lot of this ends up just being a validator choice. Each individual validator can choose how they handle whatever ingress they have. And so I think at the end state, it'll actually just be the validators choosing how they accept transactions.
But currently, I guess whatever is publicly available, so maybe what you're saying is just blind sends, and if it gets rejected. Currently, if someone were to go to build an app, if they don't have a relationship or are not paying for an RPC, they'll have that bad experience, right? So it's not that the validator or whoever the lead is getting it and saying you're not valuable unless you come from someone I trust, is it?
Well, if you are sending it directly yourself, and it takes a bit of savvy, but to send it rightly to the leader, you're fine.
Yeah. Okay.
What the RPC does is abstract a lot of that away.
Yeah.
The public RPC does is it just abstracts that away, but it does nothing else. So it's not going to help you get it to land.
Yeah.
That's what you're experiencing. If you set up your own node and you get the lead schedule and you're sending it, and you have there's a bunch of other little nuances, but if you're doing that, then you should be fine.
Okay.
The creme de la creme is like if you send through stake-weighted connection, you're setting the right priority fee, which to add is a little bit of complexity, and most people don't want to have to deal with all that. So just like anything else, you go to there are a bunch of RPC providers that are paid services, and that would just be each of them has their own model, but that would be just some amount over the normal transaction cost.
Okay.
Yeah, and so I don't know if I'm quite answering your question, but I think that the reality is there's just going to be like multi-dimensions of the complexity here.
So it sounds to me, the way you're describing it, that just the infrastructure that's publicly available that does the blind send is just not robust enough, and that if it was, is not following the leader as much? Like why? I guess why isn't it going directly to the leader from there? Why,
It is going directly to the leader, but it's just the connection is not. It's not helping you at all. It is by nature just throttled, not meant to do a bunch of ingress. So sometimes if it's overloaded, it'll just like not even start sending the traffic.
just drop the packet.
Yeah. It's not the public endpoint is just like is not a production. It's just like a test endpoint that they don't make any money off it. They just like raw forward if they have capacity to.
So
forward.
it is expected for applications to run their own or have or pay for a service that is better.
Yeah.
Like for RPCs. Okay.
Yeah. But it's permissionless. I want to be very clear about that. This is something that I think is all of this stuff you can do yourself.
Of course, yeah.
Yeah. So it's just the trade-off here is just the level of complexity in which you're going to program it.
Yeah, I think it's more of like what's available in the public infrastructure, right?
Yeah.
Like as what we're saying. I'm not saying that's not permissionless, but like publicly, it's not trivial for someone like a young startup company that doesn't have funds to spin up an application without communicating with someone and getting access to those things, right?
So some of there are endpoints. I think this is just around the maturity and like how much you expose easily. Like there's endpoints that you can just pay a little bit more, and then it gives you all the goodies that I'm describing. You don't have to have like a month-over-month contract with an RPC necessarily to get good ingress.
So like they can pass it on to the user, and the user will pay extra to get that transaction.
Yeah, but the complexity there is just knowing which endpoints have which business models attached to them. That's the complexity.
Okay.
And it's just when the ecosystem moves so fast that is probably what's hard to track. I think for the common user, yeah.
As I think
For the common dev, I mean, the users usually just use infrastructure like wallets and stuff that extract that away. So like users just have a great time, but the devs, I think that's where the complexity comes from. And like today, it's actually super easy because there's multiple RPCs that just do have free endpoints. They don't even charge you more. They actually didn't charge you even less. Like some of them will even have special routes through when they build blocks that they'll just add it into the blocks almost not for free, but like at the base fee.
Yeah.
So you don't have to have priority fee or whatever, and that's just for program deploy. Okay. So you can program deploy for a minimum viable cost, and so that exists today. But I don't know how long that'll last. Maybe that's content marketing or something that makes that a sustainable business model. So and that's just permissionless. You don't have to have a relationship with it.
So I guess maybe it might have been just we struggled to find that information. So
yeah, exactly. So there's no free
Discovery
lunch.
problem.
Yeah, there's no free lunch, right? Like there's always going to be some cost at something. And like, so it's either the public endpoint that Labs has, it just has to pay some extreme amount of money to host infrastructure. And I think this is just a design decision, is that we try to actually make some of this stuff like purposely not the best experience so that some sustainable business can. The friction there is that we probably, or somebody, somewhere in that should do a better job of routing that to the options beyond that semi-shitty experience.
Yeah. Okay. Good. I didn't know that there was that you could pay extra through certain public available ones. It seemed from like when we were going through the docs, it was basically public or run your own was kind of like the feedback we were getting from talking from other devs in the space. So I think that's really good information to know for sure.
Okay. All right. Last section is just like what use cases we were excited about in general about going to Solana, some that you might, like things you want to see go through. I'll start on the whiteboard here. So there's this thing I designed probably early summer 2022. So this is like right as we were launching. So probably like April, we launched in March. So probably about April 2022, we were talking about this. And so at the time, at the time, it was still like V2 for everything, so everything was Uni V2, and so you had this like to execute any swap was pretty expensive, right? For any of the dexes was like 25 to 30 basis points, and you had a fair amount of slippage because it was V2, so everything was applied infinitely over the price curve, right? So you would have like if you wanted to swap $5 million, I don't know, let's say ETH to USDC, you would have your core basis points plus a bunch of slippage to do that. And at the same time, on the other end in Solana, in sort of peak Solana, I think it was Solana Summer back then, maybe Eternal Solana Summer, but you had Serum, and this was like 4 basis points plus a bunch less slippage to do.
Yeah.
And so I thought at the time it was pretty interesting to design a mechanism where you can route order execution from one to the other. So I called this optimistic execution. And what you would do is if you had any reasonably sized order coming from Ethereum, so a couple $100,000 up to a couple $1,000,000, you could get way better execution than Serum. So less base bips plus less slippage, which would actually end up being like a pretty large delta. And so what I wanted was, okay, you're going to go over here and then you're going to execute, you're going to execute in the Serum pool. The problem was you don't want to do it on large trades because if Ethereum reorgs, then you get entirely wrecked on everything, right? The core of all messaging is like, you're mutating something on destination on a belief state that something exists here, and if this changes, there's no way to roll that back. And so you had this roughly like 3 minutes and 15 seconds latency, which would basically make it such that the savings you would get were not worth it. So I designed this system that was like, okay, we're going to have some amount of large assets such as lives here. Let's just say a pool of like $50 million owned by the protocol that's split between, let's just say, ETH and USDC to start. And what you would do is the moment that a trade was initiated here, you would immediately execute on this side. So this is an optimistic execution piece, but you wouldn't actually give delivery back to the end user until this 3 minutes and 15 seconds were back.
So it's basically you're waiting until it finalizes on this side.
Yeah.
So you optimistically guess that it's going to correctly finalize here, but you're just like sitting here, hold it. It's like a promise, basically.
Exactly.
That you're saying, okay, when that executes, I'm going to hold it at that price. And if it executes, then I will do the same.
So you have the execution price that you like. Worst case is somebody reorgs it, somebody spams a bunch of these and reorgs Ethereum. The worst thing they can do is make you like shift your ETH and USDC exposure. Yeah. So I'm all USDC or all ETH.
So they don't have a profit motive then. They just have like a malicious.
Yeah, you just grief me a little bit. It's it's not really that bad to rebalance. There isn't a high cost. But now, if you do this, you get the immediate execution. So you get the benefit of like a 50 to 100 bips delta benefit on all large trades. But you're trading, delivery is now 3 minutes and 17 seconds of getting delivery back. But we thought for a lot of big orders back then, you could actually have like, basically, this was the first time I was like, okay, like Solana clearly has something with like the on-chain club and all of this stuff and the ability to have like efficient price discovery. You have a world to make Solana effectively the like global routing hub where everything like routes and you do execution there, right? And so like
I think that's the end state.
And I think this is what you were solving for then with latency. Now it'll be much more interesting, and because of the way the LayerZero is structured, it's like you start with your ETH here, and like you end up getting back USDC here. So like the end user doesn't see anything, right? There's no. They start on this chain, they get it on this chain. They don't care where it goes out in routes. They don't care anything. They get the best execution price, and they just get their end asset. This is just where the
bookkeeping happens, essentially.
Yeah, exactly. And so now, if you go to like single slot finality, or you'll be able to do this in much more interesting ways. But this is the first thing that was like to me was very exciting because now I'm like, okay, you actually have like great Ethereum is great. You can route big orders from there, but you also have a lot of really long tail chains. Who have a bunch of TVL, but they don't have any depth of liquidity in the DEXs themselves. And so being able to route that out is just like very compelling to me.
100%. Like that's exactly what it gets nuanced really quickly, or maybe complex. But the dimensionality of we even see on Solana the dimensionality of having 14,000 meme coins, separate meme coins minted per day. The dimensionality across pools can be very large. So. Even if you split that out into any amount of extra layers, like that can be even larger. So we actually think that's actually why we do a lot with, like I reached out to you all a couple of years ago. We saw this potential as like a huge benefit of Solana as just being this highly liquid, low latency thing that so Circle. So maybe I'll take it back. Solana has never had a rollback in the history of the chain, just the way that the consensus works. We can go into that more. There's a YouTube on the Solana core YouTube. There's a consensus. It goes over the really in depth on why this is the case. But yeah, the idea would be it would exactly be this bookkeeping across all of the separate L2s or Cosmos or any other fragmented chain, and it would be essentially the liquidity hub where you have low slippage and then it just, that's why I was talking to you about the fees, because the main complexity in that world is just how each of those chains communicates with Sol and then back. So the fee part is actually the complexity there, not the swaps between whatever.
Yeah, and we've so also, I mean, nice part about once you get to longer tail chains is this 3 minutes and 15 seconds goes down to like 3 seconds, and then you have 5 seconds is like less than a single Ethereum block. Like the user is going to feel that as a very like relatively seamless experience. In terms of fee part back and forth, like that's something. So we at this point we're 135 million transactions, and so we've done, I don't know, in terms of gas back and forth, you're talking users have probably spent like $300-500 million in gas, maybe something like that between the costs. And so in terms of quoting and executing and doing that, like I think we've got it down to being able to predict reasonably what the execution rate will be on the other side, or at least within a bound such that it's used and useful on the user side. So this was the first thing that was very exciting to me. Okay. I would be interested for both of you of just things like what are things that are cool now that we're on Solana that people can build, that we want to see built, that we would consider building, and any of that.
I mean, the first thing is I think there's a lot of OFTs that live in the EVM ecosystem right now that want to be on Solana, and so like that's obvious. We already have that built. Like they're going to start coming, and then obviously we haven't finished the NFT portion, the NFT standard. But once that is out, there's a bunch of NFTs that want to be on that side of things. But I think this was the thing that also attracted me. Like Bryan and I
walked around that parking lot forever just debating this idea and how to actually do this. And this, it definitely opens up the opportunity to do something like this. I think this is probably one of the most compelling things, especially, I mean, I think you guys agree from your side that is what Solana is like best at.
Yeah.
And this is something that would help a lot.
Yeah, I mean, I think
everybody else.
Just giving you some other use cases of this. Like say, you just have a user who just, I don't know, they just have some asset on some chain and they have some app that allows it to do it, and they just see some point of sale. You can have some like aggregating point of sale QR code flow that on the back end, it just, even if it's not like a LayerZero yet, it just wraps it into an OFT in whatever chain, sends it to Solana to put it into whatever euro or whatever local currency they have, and then just send it back into the appropriate form and then just pay whatever that point of sale is. And it's all just, for the user, they just see some just QR code. But on the back end, it's like that infrastructure is like basically there today with the combination of like Solana OFTs. You just wrap, send, return. And then you just and then it's just up, and then so that's the end user with paying for coffee, and then all the point of sale has to do, or the coffee shop just has to do with point of sale that does the integration, and then the point of sale just has to have the QR generation and then the off ramp. And so like this is what I think is like the beauty of Web3 is like each of those individual incremental pieces takes time for them all to get together. Once they do, it's like actually not that complex per unit of piece of the stack. So I think there's a bunch of stuff that kind of like follow that paradigm.
The other thing that I was always, and this has played out much less, but I was always like, my stance was always that everybody's building everything in super monolithic fashion now. And this reminded me of early days of us building anything. I would just like build in some sort of application that would live on my computer. I would literally host it. And like my power went down. I grew up in like rural New Hampshire. The storm would come, my power would go down, and it's like application's dead. Like nobody can access it. If you were lucky, you'd put in a data center, etc. But like you build anything today, like any application, it's just like you have microservices everywhere. Like everything is hyper optimized for different pieces. And you have everything right now is being built like extremely modular in single environments. And so a ton of stuff in Ethereum only, a ton of stuff Solana only. What I thought was very interesting was eventually if you have something where you're like, okay, great, like storage, like EVM is just never going to be good at storage. It's like a bad environment for that. Like you have everything that you want, storage on Arweave, you bundle it up, you do a very complex computation on Solana, you roll the result back out to other chains. Like what does it look like for applications to be able to build a broad system that's like 2 orders of magnitude more complex than what exists right now in like a single chain environment. What does that actually unlock? Like, is it needed? Is it interesting? Does it actually unlock anything that we can't do today? But I always imagined that as chains begin to take more and more, again, like pretty orthogonal trade-offs for how they approach things, that's sort of where we see things going. I think Celestia and some other stacks were trying to do this very implicitly, but I think there's a world where, again, you have things like Arweave, like Solana, like all this other that you can kind of bundle together to get a lot of that. I don't know if you have any thoughts on Solana just as an execution layer.
Yeah, I mean, I generally think, so I get a question a lot now that there's a lot of L2s coming to Solana, or SVM just be used as L2s in other places or as their own independent. Like, what is that? Why, if Solana can scale? And I think a lot of it is, I just think of these all as just different environments. Like you can have Arweave, which is for data. We have our own ZK compression, or just compression standards for off-chain data. So there's like that off-chain data, various archival or hot forms. There's going to be execution, so maybe like all ML jobs that have some sort of attestation for either provenance or just whatever that might be, the make proofs against it. And there might be some execution that looks more like blocks that are potentially financial transactions or whatever. So Solana as like the chain is not opinionated on what interacts with it for whatever application purpose. But I think we're excited about potentially like the piecing those together. You can imagine some DeFi application that really wants to have some prediction for it permissionlessly, and as long as that prediction can prove it satisfied some condition, then it'll do some action based on that, and maybe that's gated on some off-chain data, like a DID or something, some big payload, and you'd have that attestation. So that's like something pretty complex where you have these maybe like automatic DeFi or these agents acting on a chain or something in some sort of permissionless way, where it's just these different pieces of the tool chain kind of interacting. You have a large ML job, and then you can, so you have, maybe you have some archive of some price data, all right, and then you want to have some ML job, which is just some, I'll just do like, this is my little robot here, my little agent, okay, and then this is going to pay through like the chain for some data payload, and it's going to receive it, and then it's also going to produce back some prediction, all right. And then there might be some other, and that's just like some price feed. That's something else. Maybe there's another bot that says, has some logic that like, based on that price prediction, I'm going to take some other some action. It's like a listener. So there's going to be some listening back and forth, and then it's going to execute on some other, executable code. So you have like multiple steps here, and maybe this thing is like, I'm doing a pretty good job. I'm starting to get paid by some other things. It can request out to even more compute or even more whatever to do a better job and get paid more. And if it sees that as a beneficial thing, it'll keep on asking for more. And maybe there's other things. Like maybe this is there's like some.
This is where the paperclip problem starts with compute. Yeah. Just a single agent just can.
Yeah, but the thing is like maybe there's some lending or whatever, and it needs some like attestation on, I don't know, some sort of registry of past information that it like can call on or whatever. But I'm just describing like an arbitrary number of things here, because the cool thing about this complexity is it, like we were talking about earlier, just like a number of business relationships. That's why that question matters. Is like, I don't want to have some new entrant, come in and have to like form a business relationship with each entity that's already in the system. I just want to like look at something that I see an opportunity and just execute on it. That's why public endpoint matters and all these whatever, because if I can just do that, then that unlocks this whole ecosystem to kind of self-form instead of having to have it gated through something. And so, I can just see these applications just kind of blow up in complexity where each individual part of the stack just knows, I just need to provide my price feed, I just need to ask for resources, and this other one just needs to know to, execute some DEX order or whatever. But like in total, the product that's being served to like an end user that's over here is like, yeah, I have like $10. I'm just going to put it into this thing. You're giving me some sort of risk-adjusted quote, sure. And then behind the scenes, like something crazy can happen, but this person is just like, yeah, I'm kind of like beating the market on my $10. It goes to 11, yay. Or maybe it's something more customized to it, where I want some generative art. And I don't like that one. I'm going to downvote that one. I'm going to upvote that one. Instead of just Google, instead of only Google being the arbiter of what next thing I'm going to be given, maybe there's like a bunch of opportunity for independent operators to satisfy that to get my dollar. And so I want to see this world where instead of again just Google taking my up and down votes, I get 10,000 entrepreneurs seeing if I can please this user enough so they start paying me for future generative AI, whatever content. And again, behind the hood, you have a bunch of just computers generating addresses to pay and get paid and all that stuff. They don't have to set up Stripe accounts. They don't have to set up whatever else. They can just serve that user however they want.
Yeah.
Cool. And in this scenario, this self-forming thing, besides this, the actual, you're saying this is Solana in this scenario, right? So
I mean, I think like we were describing earlier, where like Solana in these scenarios, whether it just be maybe some user has some bot is operating on some ML specific chain or whatever. Solana in this case is like this highly liquid area where this stuff happens as low as friction as possible.
Yeah.
Because there's, like the more and more complex these things get, the harder and harder it is for an ecosystem that serves some amazing product to form. So Solana is really there just to be as frictionless as possible connected those layers. We're not opinionated that they have to be tokens. Tokens are just the easiest thing to talk about because that's what it looks like today.
Yeah.
But like any bits of information. That's why I really like the way you even describe what LayerZero is. It's like you're a protocol to be message passing. Solana is something that processes whatever arbitrary messages as efficiently as possible, and it's up to the applications to describe what that is.
Yeah. Makes sense.
All right. I mean, I think that's pretty much it. Matt, thank you so much, man, for coming on, and nice to be able to just sit down, debate a little bit, talk whiteboard through some ideas. It's really awesome.
Thanks for having me. This is great.
Cool.
Yes.